begin. Welcome. So I'm going to go over this practice test going with dimensional analysis and into sig figs. I will try and keep sig figs consistent throughout the entire video, but without further ado, let's jump in. Let's automatically start with number one, where we're taking 500 meters and we're going to kilometers. So first thing I'm going to do is make my big parentheses. I see meters on the top. I'm going to drop it like it's hot down to the bottom. Using my conversion, I have meters and kilometers. So I'm going to put kilometers in the only remaining space, which is the top. And then I see that 1,000 goes with meters and 1 goes with kilometers. Cross out my units, and I remain with kilometers on top, which is exactly what I want. So this math works out to 500 divided by 1,000 kilometers, which is the same thing as saying 1/2 kilometers or 0.5. Now I'm going to say 0.5 kilometers, and you might be asking, Mr. Garcia, how many sig figs are we looking at? Well, I'll try and do, let's say blue is sig figs. In my first number, I only have one significant figure. These zeros in the back here are going to be not significant. Not significant. And that is because trailing zeros are not significant if there is no decimal. So we only count them if there's a decimal. So we only have one sig fig, which means our answer should also have one sig fig. All right, and that is number one. Moving on to number two, 2.5 hours. I'll just say 2.5 hour. Again, we're going to go ahead. I see hour on the top, drop it like it's hot, hour on the bottom. If it's on the top and bottom, it will cancel out. Therefore, seconds is on the top. I see that I have seconds here and hours here, and 3,600 goes with seconds. My bad. 3,600 goes with seconds, 1 goes with hours, and we're going to be doing 2.5 times 3,600. Let's cross out our units so we don't forget. And we see that seconds is on top, so seconds will remain. And we're going to put this in our calc. And we get 9,000 seconds. Now, this one's a little tricky when we talk about sig figs. If we look at our first number, we have 2 sig figs. Now, in the middle here, this is exact, so these will count as infinite sig figs, or we just don't take them into account in our equation. So that means our answer needs to be in 2 sig figs, but that's kind of an issue because these zeros in the back are not significant because we don't have a decimal. But if we go ahead and throw that decimal in, suddenly they're all significant, and that's 4 sig figs. So that's a problem. So we need to figure out how to solve that problem. And it's really easy. What we're going to do is we're just going to pop this into scientific notation, and we'll say 9.0 times 10 to the third seconds. This is the same thing as 9,000. These two numbers are equivalent. The only difference is the top number right here has 1 sig fig and the bottom number has 2. So this is going to be our correct answer. So scientific notation helps you get out of these weird sticky situations with sig fig. So we're going to keep that in mind as we keep going. All right, moving on to number 3, 3.5 kilograms into grams. I mean, we're kind of doing the same thing over and over again. Kilograms on top, put kilograms on the bottom so that they cancel out. I notice kilograms and grams, so the top part is going to be grams. We have 1,000 with grams and 1 with kilograms. So we will cancel out our units. We are going to see that we end in grams, which is exactly where we want to be. This is going to be 3.5 times 1,000. Grams, which is just going to equal 3,500 grams. Now, in this case, when we look at sig figs, we have 2 sig figs and we have 2 sig figs. So we're pretty good. You can write either this or our 3.5 times 10 to the third grams. Either way, they're both correct. They both demonstrate two sig figs right here. So I'm happy with either. All right, moving on to one of our more challenging questions right here. 75 miles per hour. We want to convert that meters per second. So what we have to do here, and I'll actually try and make this a little simpler in the way I write it. I'm gonna say miles over hour. That's 75 miles per hour, which is not really the speed limit, but pretty close to it if you go on the 5 in California. And we're gonna just focus on one unit at a time. Right now, we're gonna go ahead and focus on miles. So we're gonna drop miles to the bottom so we can cancel it out. We see that 1 mile. Oh, I said I was going to keep things consistent, so I will go ahead and do that. 1 mile is equal to 1609.34 meters. And that's going to go ahead and cancel mile with mile. And we'll end up with meters. So now we have the correct variable on top. But we still have hours on the bottom over here. We need to change that into seconds. And this is where it gets a little tricky. We have to move back to that idea of algebra. If I want to cancel hours and it's on the bottom, that means I need to put hours over here on top, because if something's on the top and the bottom, then we can cancel those units out. So I'm going to go ahead and throw hour on the top, and I know hours goes with seconds, 1 hour, 3,600 seconds. And I can cancel hour and hour. And now on the bottom, I have seconds. So I know that when I do this math of 75 times 1609.34 all over 3600, I will still also be multiplying by meters on top, seconds on the bottom. And so we're going to go ahead and put this into our calculator. And we get 33.528 meters per second. But something's not right here. We need to take into account sig fig. So let's go ahead and look at our various numbers. This conversion here, 1 to 3,600, this is a time, this is set by people, this is certain. We're not going to look at sig figs in here, no sig figs. Over here, this is a conversion converting between imperial and metric. And when we have that, one of these numbers is exact. It's going to be this one down here. We're saying 1 exact mile. But the other is dependent on how well we can measure. This guy right here. And apparently in this instance, we measured up to 1, 2, 3, 4, 5, 6 significant figures. So we're going to have to take that into account. This has 6 sig figs. And then lastly, our original given only has 2 sig figs. So in multiplication, we go with the lowest one. So we're going to shorten our answer down into 2 sig figs, which will just be 34 meters per second. 34 because this 5 right here makes the 3 round up. So with that said, we'll move on to number 5. And I'm actually going to show you 2 ways to do this. So let's go ahead and do way 1. So 450 square feet or feet squared, same thing. And we're going to go ahead and put feet squared on the bottom and meter squared on top, because square foot and square meters just means feet squared and meter squared. And we're going to say this is 0.0929903. And on top we have, oh, my mistake. See, even I make mistakes. In this one, the number goes with meters. So we're going to say 0.092903 square meters is the same as 1 square foot. We have so many sig figs on top, but we only have 2 sig figs on our original number. So I'm just going to cut to the chase and say our answer will only have 2 sig figs. And when we do 450 times 0.092903, and our feet squared, cancel with feet squared, and we'll end with meter squared. Put that into our calculator. And with our two sig figs, we get approximately 42 meters squared, or square meters. Now, that's the first way to do it. I'm going to show you a second way right down here. 450 feet squared. And instead of saying feet squared, I'm actually going to take feet squared and change it to feet times feet, because feet squared really is just feet times feet. And so we're going to instead also use a different conversion. We're going to use the conversion of 1 foot is equal to 0.3048 meters. And I'm going to show you something interesting we can do here. Because we split foot into feet, which is the same thing as feet squared, we can do this conversion one at a time using that. So we go 1 foot is equal to 0.03048 meters. Now that cancels 1 foot out, but it doesn't cancel the other foot out. In addition, we only get 1 meter, not meter squared, so we actually need to do it again. 1 foot, 0.3048. And I realize I made a mistake over here. Let me just correct that one. 3048 meters. This foot cancels with this foot, and now we have meter times meter. So our answer is going to once again be in meter squared. And when we do this math out, a 450 times 0.3048 times 3.3048, we still get the same answer. We get 42 meters squared. So there's a lot of interesting ways to do this. The third way, I lied, there were 3 ways I'm going to show you instead of 2. So the third way, and the third way actually comes from the second way. It comes from the second way so much that we're pretty much going to copy it. 450 feet squared. And we're going to do 1 foot is equal to 0.3048 meter. But the problem here with this one is that I have feet squared, and feet squared doesn't cancel with feet. So I need to make an adjustment. In this one, I will square the whole parentheses. And when I do that, it's actually exactly the same as this parentheses above it, because that parentheses squared is the same thing as putting 2 of them next to each other. So method 3 and method 2 are exactly the same. The only difference is your calculator has one slightly easier task, because you're just doing 450 times 0.3048 squared. So you have to type less into your calculator, but it's otherwise the same thing. So with all that said, I'm going to go ahead and just move all this back up. And hopefully I've got enough room for my next problem. Now, this next problem right here is just a little complicated because I'm using chemistry units. I'm using grams, I'm using moles, but the truth with dimensional analysis is you don't need to know grams or moles. All you have to know is dimensional analysis. So we're going to start with our given 56 grams H2O. And I want to convert 2 grams of CO2. Well, I'm going to take grams of H2O and drop it on the bottom. Then I'm going to go ahead and look through my conversion factors to see what has grams of H2O. And oh, look, there's only 1. So I'm going to go ahead and use this one conversion factor. Grams is on the bottom. That means I'm going to put moles on the top. So I will put mole H2O. And following the numbers, it's 1 and 18.02. Grams cancels, and I will move on to my next one. If I discount the conversion factor I already used, and we look at our next one, well, I have mole on the top, so I'm going to put mole specifically of H2O on the bottom. I have what's on top. I'm going to drop it like it's hot down to the bottom. So I'm going to look at my conversion factors, find the one that has mole of H2O. There it is, right here in the second line. And within this one, if mole of H2O is on the bottom, mole of CO2 is on top. mole CO2. And I see that it is 2 with that and 4 with that. And I'm going to go to my last parentheses. Running out of room here, but that's all right. Mole of H2O cancels. I will get rid of this conversion factor I just used. And I will use the last one. I know that if I have mole of CO2 on top, I'll have mole of CO2 on the bottom, because what's on top has to go on the bottom so that we can cancel it out. And on top, all we're left with is gram CO2, which coincidentally, when we put our numbers in, is the unit we wanted to end with. We wanted grams of CO2. So I'll go ahead and cancel that out. And we can go ahead and throw in our calculator. I'm going to move this under 56 divided by 18.02 times 4 divided by 2 times 42.01. And I'm going to end up with gram CO2. And let me go ahead and type that into my calculator real quick. And when I type that in my calculator, I want to show you, I'm actually just typing that line of inquiry into my calculator, 56 times 18.02 times 4 divided by 2 times 42.01. I'm not making any changes. I'm not doing any formatting. Whatever I see on the top of my equation, so whatever is on the top is going to be a multiplication. Whatever's on the bottom is going to have a divide. And then I can just go ahead and hit enter. Oh, I hit not enter. Hit enter, and I get some big number. And that's all right. Big numbers are totally fine. We can use them. This big number is, oh, this number is too big. In my calculator, I got 84,000 about. And just doing some quick mental math, I realize that 56, a power of 10 divided by another power of 10. So something in the tens, something in the tens should be somewhere in the ones. So 56 divided by 18 should be somewhere around 2.5 or 3, probably closer to 3, times and divided by something in the power of ones times something in the power of tens. I should have something in the hundreds probably, but I don't. I have something in the thousands. So I know I made a mistake. So I'm just going to look at my calculator. And for those with really keen eyes that can pause the computer will notice that I actually put a multiplication before my 18.01. So I'm going to go ahead and change that to a division. And then I should get something. Yeah, there we go. Something in the hundreds. I got 261.1 grams CO2. Now you might yell at your screen and say, Mr. Garcia, what about sig figs? Well, let's go ahead and look. So first off, our first number has 2 sig figs, 4 sig figs. These are exact. And we don't have to worry about the sig figs on exact numbers. These are 4 sig figs. And so our lowest one is 2. So I should actually go ahead and convert this back to 2 sig figs. So I'm going to go and write our proper answer as 260 grams CO2. Also okay to write 2.6 times 10 to the second grams CO2. Both are acceptable answers. So I'm going to go ahead and leave that there. And we'll move on to our significant figures. And some of these get a little tricky. So we'll count them all out. So in number 1, zeros in the beginning don't count. But this whole number, and this whole number that are all non-zero count. So that's going to be 3 sig figs. This one's a little tricky. Definitely that's a sig fig. Definitely that's a sig fig. But what about these zeros? Well, the rule is if there's a decimal point, they count. But now you're asking yourself, does this decimal point come from the fact that it's at the end of a statement or because it's in a number? You know, the truth is that's a mistake on my part. So you could either say 2 sig figs or 1, 2, 3, 4, 5, 6 sig figs. Both are correct in this case. I'll try not make that mistake when you're actually taking your test. All right, moving on. Non-zeros are definitely significant. Zeros between non-zeros are also significant. Scientific notation is just a multiplication factor. It is not a measure of exactness, which remember, significant figures measure our certainty. Measure certainty. Or how exact we are about our guess or number. So this is going to be 3 sig figs. Moving on, 100.5, significant, significant, and then all the zeros in between, significant. That's 4. All right, leading zeros, not significant. Who cares about them? 5, definitely significant. And then the question is, what about these following zeros? Well, if we look past all my scribbling, we'll notice that there is, in fact, a decimal point right there, meaning our trailing zeros are significant, 3. All right, we have a significant and a significant, non-zero numbers, and therefore all of these in between are. So that's 1, 2, 3, 4, 5, and 6 sig figs. All right, we measure the length of my pencil, and we say that it is 17.8. Not even a single zero. These are all significant, 3 sig figs. Now we have, coming up on our last couple, we have definitely significant, definitely significant. In between two non-zero numbers, significant. At the end, only significant if, yep, there's a decimal. And then beginning, never significant. So that's 1, 2, 3, 4, and 5 sig figs. All right, last one, zooming in because it is just the final one and we're excited. We have a significant non-zero, a significant non-zero. This zero is only significant if we have a decimal point, and we do. So this one is also significant. We have 3 significant figures. And with that, those are all the major problems on this practice test. So I hope this helps. If you need any help, rewatch these parts again or ask me, slow it down, speed it up. Have fun and have a good night.